So today we are going to look into this problem, the problem number 209 in lead code, and the title is minimum size subarray sum. As you can see, this is a medium level question. That means it's a little bit tricky, okay? And you can see the title itself, right? Minimum size and subarray. Subarray itself means a sliding window. So whenever uh, you see the constraint matrix in the questions, you should uh, think about the sliding window, right? So let's read this question and we will see how the sliding window technique is very efficient to solve this question. So given an array of positive integer sum and a positive integer target, written the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, written 0 instead. Okay, so let me rephrase the question. You will be given an array of numbers, integer, all of them are positive integer, and you will also be given a target number. The target, so that's are the two inputs, right? Target and the array of positive integer. And you need to find out the minimal length of a subarray, minimal, okay, whose sum is greater than or equal to the target. Okay, so let's say first, if you see the example number 1, we have given the positive integer array of 6 elements, 2, 3, 1, 2, 4, 3. Okay, and we have also given the target number is 7, and we have to write an algorithm that will return the minimum length. So we need to identify the subarray. As we discussed, the subarray is the contiguous numbers, right, that maintain the order in the array, right? So we need to identify the subarray length, right? Whether it can be a single element, two elements, three, four, six, whatever it takes. What we have to make sure that their sum, when we add the element in the subarray, its sum should be greater than or equal to the target. And we have to find the minimal length. Okay, minimal length. So for example, in this one, 4, 3, if you see the 4, 3, okay, that makes it 7. It can also make, if you add the subarray 2, 3, 1, 2, like the first, uh, yeah, there is no such other element, right? Yeah, 1, 2, 4, right? That's also, so the element 1, 2, 4 also making the sum as 7, but that has the length 3. On the other hand, 4, 3 also making the sum as 7, and their length is 2. Similarly, if you add the first four numbers 2, 3, 1, 2, that makes the sum, which is 5, 1, 6, 8. 8 is greater than 7. So that's also satisfying this condition. So we have found subarray 2, 3, 1, 2, like with the element like the 4, and then 1, 2, 4, that's 3, and 4, 3, that has only 2. So we have 4, 3, 2. These are the subarray we can form out of the given array, and that we have to return only the minimal length, which is 2 in this case. So let's see this in how we can represent this, and we can work with some drawing, and let's see if it helps you to understand it better. So here is the the first example, we have the positive integer array. The elements are 2, 3, 1, 2, 4, 3. Okay, so that's my nums. And the target value is given is 7. Okay, we need to identify, we need to find the subarray of minimum length. Subarray of minimal length, which is, so if you examine this given array, you will see, okay, this will make the sum equal to 8. 2 plus 3, 5 plus 1, 6 plus 2 is 8. Similarly, if you see from here to here, right, it's 3 plus 1 is equal to 4 plus 2, 6, 6 plus 4 is also 10, which is greater than or equal to 7. So this length is again 1, 2, 3, 4. The upper length is also 4. Then we take from 1 to 4. It's the sum is 7 and the subarray length is 3. Then we move to this. The sum is 2, 4, 6 plus 3, 9, and the length is 3. And then we move to the last two elements. So the sum is 7 and the length is 2. Okay. So the first subarray, we have subarray that is 2, 3, 1, 2. The length is 4. Sum equal to 8. Second, 3, 1, 2, 4. So length is equal to 4 here as well, and the sum is 10. Similarly, the third one is 1, 2, 4. Sum is 7. Sum is 7. Length is equal to 3. Sum is 7. And then the fourth one is 2, 4, 3. Length 3. Sum equal to 9. And the last one, fifth one, is 4, 3. So length is equal to 2. Sum is equal to 7. Right? We see the length 4, 4, 3 right here, the length one. Okay, and this is as well. So as per the questions, we have to return the minimal length, right? So our algorithm should return 2, okay, because this is the minimum length we have. And yeah, so we have to write an algorithm that will efficiently return the 2. It's uh, it's a little bit tricky, right? Because you can see like there are so many combinations if you are adding the numbers in the given array. And this is just one example. It could be more bigger array. It's just like 7, right? But it could be a more bigger. So you have to add, like you have to move from the 0 index to the end of the array and keep finding the sum. And as long as it is greater than or equal to 7, that's the length you are looking for, and you have to find the minimum out of this, right? So first you calculate the length and then you have to return the minimum length out of it. So let's see. So this is the problem. I hope you understand the problem statement and what you need to implement uh, to get the result, what you need to implement so that it will return the correct result. Now, using the sliding window, how are we going to solve it? All right. So as you can see, this is the length, right, from the length of this array is how many elements, right? We have 6, right? So 6 is the length, and we can have, like in the worst scenario, the minimum length is would be 6. That's the worst scenario. And what we have to do is we have to start from the 0 index right here and keep moving, right? As long as the sum is greater than or equal to, once we reach that, it is either 7, right? The minimum length is 7. So as long as it's greater than or equal to 7, that is the length we are looking. So for example, we start from this index here. We are adding the sum. We are creating a sum. So we add the 2 into this one. That makes the sum is 5. And we'll keep moving. And we are adding the numbers and keep tracking of the numbers, and so as well as the index, right? How we are moving. So as soon as we reach this 2 here, right, that makes the sum as greater than or equal to 7. So it satisfies this condition at this point. So this point, we find the first minimum length, which is less than this 6 right here. Okay, so now the length is 4. So we find the length 4. Now we have to move. We have to move our window. So we should move out from the 2 and we should start from 3. Okay, so we start from 3 and we keep doing it. Okay, now how we gonna do it? We should, as I think the best way to do this is, like, you already have the sum, which is whatever the sum is right here. So it's 8. Now you should take out the number 2 because you are moving the index out of the 2. Now your window is starting from 3. Okay, this is the starting index. So whatever, and you are currently at this 2, this location. So from 3 to 2, the sum is should be 3, 1, 4 plus 2, 6, right? So simply you remove the number, the element from the sum whose index you just moving out, right? So this was the 0 index. It was the part of the first window where we reach the sum is greater than or 7. So once we move our window to the next index, we need to take out this number. Okay, and we need to restart the sum. So sum is up to here is already 6, and we're gonna add the new number, which is 4. Now the 4 will add the new sum will be 10, and this is the new length. Similarly, now once we reach this target, which is it satisfy this condition here as well. So we're gonna move, we're gonna get rid of the 3, the value at this index, and move the window to the next index, and so on. Okay, as long as we keep doing that, and we have to keep track. So a few things we need to keep track. First, we need to keep track of the sum. Second, we have to keep track of the length of the subarray or the window, whether it's what is uh, the length, right? So in the first one it was 4, second it's also 4, and then it reduced to 3. So we have to keep track of the length and the sum, right? So let's see how we can implement this using Java. So let's implement this algorithm using the sliding window technique. So as we talked about, we need a variable that will keep track of the sum. So I'm going to define a variable that is going to uh, hold the sum. Then we need a left pointer variable that will be pointing to the first elements of the array. And we also need a right pointer, or we can simply say the minimal length variables that is going to hold the that's gonna be the result what we are looking. So I'm going to def I'm going to say that will be my integer dot max value. So that's why I'm going to define. So this is the max value, right? I need something to hold that. And we need to make sure that in the end, right, if we don't find a subarray that is the sum of that subarray is greater than or equal to 7, we have to return to 0. So that's why this I'm assigning this to the max value so that once we when we run through the whole array, we will compare this value, and if the minimal length is equal to the max value, then we just need to return the 0. So that is the minimal length variable that will hold the minimal length of the subarray whose sum is greater than or equal to the target value. So now what we're gonna do is we're gonna iterate through the array, okay, from the 0, and we're gonna keep going until we reach to the length of the array, okay, and I plus plus. Then the first thing we will do is every times in the window, right, we are starting from the left pointers, the first very at the very beginning, both the pointers, left pointers and the right pointers, the I is the right pointer here, is going to be the same value, so pointing to the same elements. And what we're going to do is we're going to simply add it to the sum, right? Sum is 0 initially, and we're going to keep adding the numbers. And we are also going to check if my sum is greater than or equal to the target value. Okay, if it is target value, we have to update the minimal length, this value here, right here. So this one we have to make sure it is the minimum one. So for checking if it's minimum or not, I'm going to use the mathlib that will give me this min method, and here I'm going to compare this min value against the current index value, right? So how do I calculate the current length of the subarray if the sum is, so my right index is currently I, and I'm also adding 1 to that, and then I'm going to remove the left pointer from it. So that's how the new length will be, and whichever is minimal from this two, right, then that will be holding into the minimal length. Then next thing we talked about, right, once we removing the left pointers, the new window will form, right? And for the new window, we have to make sure that we update the sum. So which means, right, we need to subtract it, uh, the left pointers value from the sum, and also need to increment the left pointers. So our window will update. So that will be the new window. Okay. And this will keep we have to do the whole logic until we are done with the array, or we reach the end of the array, right? And in the end, we simply return the minimal length, right? Now, here is the thing. The minimal length is initial value is the max value. So there might be cases that we have given an array whose sum is not, like if we add all the elements is not equal to the target. In that case, we need to make sure that it's not equal to the integer max value, right? This is the value where we initialize it so that we can easily compare. So it's a max value in, and if it's not equal to the max value, then we simply return the result, else we gonna return the 0. Okay, so that will be it. So let's run this question. and see how it goes. So we got an exception is result. Oh, I'm sorry. So we have to use the minimal value and then run it again. And you can see that that looks good. Yeah. So that's it. Thank you so much.